Okay, so here's a presentation about the Pythagorean theorem. The overall compelling question is, throughout the history of mathematics, a compelling theorem emerges where for any right triangle with sides A and B with the hypotenuse h, the square of h is equal to the sum of the squares of the other two sides. So where does this theory come from? How and why does it work? How will this apply to the real world? And this is a supporting question. Yeah, and basically for the next few slides, we're gonna be focusing on answers this question. Okay, so how this develop it? It's said that it's difficult to pinpoint the exact origin of the theorem, but many people has proved it and contributed to the understanding of the theorem throughout the years. But however, one of the earliest recorded use of the Pythagorean theorem was in the Egyptian era. So we got this Egyptian worker. What they did was they used a rope and tied like 1, 2, 3. How many is that? 12 knots, and they have three knots here, 4 knots here, and 5 knots for the longest side. Basically, what it does is form them a right triangle, and from there they can do like things like build the big pyramid thing. Yeah, okay. But however, the Pythagorean theorem is largely credited to this guy. His name is Pythagoras of Samos. He's a Greek mathematician, and the reason why is because he was the first one to wrote a no proof. So basically, what this slide tells us is the theorem has been like thousands of years ago, but this guy, he's the first one that wrote a proof for it. People credit him for the name of the theorem, the guy's name. So how does this theorem work? So in here we have two sides. We call them legs that form the right triangle. We name them, label them A and B. Okay, and for the hypotenuse, it's the longest side. It's the side the opposite of the right triangle. It's opposite. You can see, it's the right triangle. It's opposite. This is the longest side. I label it C. Okay. So the theorem states that for any in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the length of the other two. So basically, the square of C square is equal to A square plus B square. Okay. And oh yeah, why does this theorem work? So mathematicians use existing mathematical rules and logic to demonstrate that a theorem must hold all the time. Well, this hold true. Okay, so basically there's many proofs that this theorem is true. First we have the rearrangement proof. Let's see, you got obviously two square here, they equal in area, and you can see there's B square. Okay, we have how many triangles? It's 1, 2, 3, 4. 1, 2, 3, 4, and they both have 4 triangles. Okay, and look at the right one. So this area will equal to this white area, and the reason why is because these two triangle it's preserved the size and it's moved to here. So basically what it's saying is the white areas is equal to the white area of the second square. And the reason for that is because these triangles, they preserve the size and they come to the second square. Okay, it's not as confusing as it sound. I'm kind of stuck at explaining it, but this one is to be easier. So it's a waterproof. So if you get a right triangle and you like take the square up this side and swap this side and basically swap this side, you feel water in each one, like the image here, and then you flip them over, this water we filled up both of these squares like equally. There's no water left in this thing. So yeah, the Pythagorean theorem has more than 350 proofs. So these are just two proofs that held accountable for the theorem. Okay, and what else do we got? Okay, let's put it to work. So we got the triangle with 4 and 3. Our problem is trying to solve for C. Okay, let's do that. So we know that if we apply the theorem, so I'm doing this pretty quick. So 4, that's A. So substitution, you got 4 square plus B, that's 3 square equals C square. So you got that's 16 plus 9, that's 25 equals C square. And now you got 25 equals C square. All you have to do is square on both of them, and you solve for C. C is equal to 5. Yeah, pretty easy. Here's the real world applications of the Pythagorean theorem. So in sports, we can have like calculate distance in the field. For example, the baseball diamond, like over here. You can see like yeah, they can form two right triangle. Okay. In navigation, you got to determine the shortest distance between 2 points. So yeah, this is the shortest distance. I mean, pretty cool. Then in engineering, we have building bridges, and see, yeah, they got a bridge here, and I actually have no idea what this image is saying. It's wind and something have to do with the plan. Is a right triangle. So yeah. Oh, okay. We got the distance formula. So the distance formula is basically what it's trying to do is calculate the distance between 2 points. So here we have A and B. It is derived from the Pythagorean theorem. So if you draw a vertical line and a horizontal line like this, like the image, it will create a 90-degree angle. And that will form a triangle like the image, where we have the green segment is equal to the hypotenuse. And how this is derived from the Pythagorean theorem is, well, when looking at the formula, we see that the coordinate of x1 and minus the coordinate of x2 square. What this does is that you find the user length of this segment here, and you square it up. This is the same thing applied to here. So according to the Pythagorean theorem, this side should be A, and this should be B and C. And then once you find the segment of each of these two legs, you square them up, and then you add them up, you square root the answer, and that will give you C, which is the distance of this segment. So basically, that's why really the distance formula is just Pythagorean theorem in disguise. Here's some key takeaway. So the Pythagorean theorem only applies to the right triangle. This is a formula a square plus b square, where c is the hypotenuse. It helps us find the missing length of a right triangle when we know the other two. And it has many real world applications. Thank you.